Deep within the remote, high desert basin of northeastern Utah, a towering ridge of crushed sandstone and dark shale, known simply as the Mesa, has stood for decades as the physical center of gravity for one of the most intensely scrutinized land plots on Earth, Skinwalker Ranch. To a casual observer traveling along the rural roads of the Uinta Basin, the 512-acre property resembles a typical western cattle ranch, an expanse of dry pasture, irrigation canals, and weathered scrubland framed by towering rock formations. Yet beneath this tranquil surface lies a paper trail of anomalous field logs, military contractor reports, and peer-reviewed scientific studies that suggest the geology of the Mesa is far more complex than simple erosion and sedimentary uplift. For more than 30 years, public interest surrounding the ranch focused primarily on atmospheric anomalies, unexplained aerial light phenomena, sudden spikes in localized microwave radiation, and persistent radio frequency broadcast recorded across the pasture. However, ongoing investigative efforts by independent researchers, geophysicists, and specialized engineering contractors have increasingly shifted focus downward toward the bedrock itself. High-resolution terrain mapping, satellite thermal imagery, and multi-frequency ground-penetrating radar surveys conducted along the northern talus slope consistently indicated the presence of anomalous void spaces hidden directly behind thousands of tons of fallen boulder fields. What intrigued researchers was not merely the existence of subterranean cavities, which can occur naturally in limestone and soft sandstone strata, but the peculiar structural geometry returned by deep scanning acoustic sensors. Subsurface radar profiles gathered along the base of the mesa revealed a distinct linear void extending horizontally into the ridge at depths between 40 and 80 feet. Rather than displaying the irregular, branching patterns characteristic of water-carved caverns or natural fault fissures, the return telemetry outlined a subterranean conduit with remarkably uniform dimensions, a feature measuring approximately 8 feet in height running parallel to the cliff face. Initial attempts to verify these radar signatures through vertical core drilling met with immediate unexpected technical obstacles. When tungsten carbide and industrial diamond drill bits were driven into the calculated grid coordinates, field crews experienced severe bit binding, unexpected mechanical shearing, and extreme frictional heating at depths where soft rock should have yielded effortlessly. Slurry samples flushed from the boreholes contained trace amounts of highly refined silica shards and microscopic metallic filaments that did not match the metallurgical composition of the drilling equipment itself. Faced with mechanical resistance from vertical drilling, project managers authorized a direct horizontal excavation along the base of the mesa to clear the talus field and locate the physical source of the radar anomalies. Utilizing heavy earth-moving equipment under continuous environmental, radiological, and radio frequency monitoring, excavation crews systematically cleared tons of crushed sandstone blocks. As the final layers of rock debris were carefully removed, environmental monitoring equipment positioned around the excavation zone registered a sharp shift in baseline conditions. Handheld spectrum analyzers picked up localized, high-amplitude radio frequency bursts centered at 1.6 GHz, a specific frequency repeatedly documented across decades of ranch logging during anomalous field events. Simultaneously, air quality sensors flagged a steady outward draft issuing from between the newly exposed rock faces, bearing a cold, metallic odor and ambient temperatures significantly below the surrounding desert air. Clearing the remaining structural blockage revealed a dark, rectangular opening extending directly into the cliff wall. The passageway was roughly square, with walls exhibiting clean, linear impact patterns consistent with deliberate physical excavation. As a forward survey team equipped with hardwired fiber optic video systems, atmospheric scrubbers, and multispectral sensors stepped past the broken rock threshold, thermal imaging cameras logged an immediate temperature drop, falling from the high 90s outside to a chilled 38 degrees Fahrenheit inside the corridor. Advancing nearly 80 feet into the darkness, the team reached a widened subterranean chamber anchored by a heavily reinforced, non-corrosive metallic bulkhead partially embedded within the vitrified rock wall. Positioned on a natural stone ledge near the base of this portal lay a calcified biological specimen approximately 4 feet in length. The physical discovery featured an elongated cranial structure, distinct non-human skeletal proportions, and a dense metallic-like residue embedded directly within its preserved dermal tissue. As multispectral scanners swept the specimen, surface monitoring equipment, positioned directly above on the Mesa top, logged a massive synchronized spike in localized magnetic field strength, confirming that the unsealing of the subterranean corridor had triggered an immediate physical reaction throughout the ranch's environmental network. The immediate discovery of a calcified biological form at the threshold of the subterranean bulkhead prompted an instant shift in field operational protocol. Rather than proceeding deeper into the chamber, the forward team halted movement to establish a controlled biohazard and environmental containment perimeter. Portable clean tents equipped with positive pressure air scrubbers were routed through the fiber optic tether line from the surface, isolating the specimen and its immediate surroundings from external atmospheric exposure. Initial non-invasive multispectral sweeps of the 4-foot biological entity yielded diagnostic telemetry that challenged standard comparative anatomy. The specimen exhibited an elongated cranial structure with lateral orbital depressions, lacking the pronounced auditory or facial features typical of terrestrial mammalian skeletons. Preliminary solid-state radiographs indicated that its structural framework was composed of a semi-flexible cartilaginous matrix reinforced with dense crystalline calcium phosphate deposits, anatomical architecture providing high tensile strength while maintaining a lightweight physical footprint. What caught the attention of on-site material scientists was the specimen's outer dermal layer. The dark, vitrified tissue showed no signs of standard biological decay or fossilized mineralization. Analysis using a portable X-ray fluorescence spectrometer revealed that the outer skin was intermeshed with microscopic, overlapping scales containing high concentrations of a refined titanium nickel matrix. This metallic structure closely matched the anomalous alloy flakes previously recovered from the Mesa core drilling slurry, suggesting an integrated biosynthetic interface engineered to withstand intense thermal and radiation stress. As bioimaging technicians positioned ultrasonic sensors around the specimen to map its internal structural layout, environmental monitoring stations inside the containment tent logged a sudden thermal fluctuation. The ambient air temperature surrounding the specimen rapidly climbed from 38 degrees to nearly 68 degrees Fahrenheit in under 4 minutes, without any external heating source applied. Concurrently, high-frequency spectrum analyzers registered localized rhythmic energy bursts at 1.6 GHz, emanating directly from the specimen's cranial region. This energy output was not isolated to the subterranean vault. On the surface above, monitoring stations across the central pasture recorded a simultaneous 300 nanotesla rise in local magnetic field strength. Optical camera arrays mounted along the northern ridge captured a subtle refraction effect in the air above the pasture, a localized warping of ambient light mirroring atmospheric distortions recorded during previous high strangeness events on the property. Inside the vaulted chamber, the 1.6 GHz transmission began to synchronize with a low-frequency acoustic vibration vibrating through the vitrified floor. Audio receivers captured an infrasound wave measuring 19 Hz, a frequency known to interact with human auditory and nervous systems, inducing mild spatial disorientation among the shielded research personnel. The physical evidence suggested that the specimen was not merely a passive biological remnant. Its metallic embedded tissue retained residual electromagnetic properties that reacted dynamically to the environmental changes brought on by unsealing the shaft. To stabilize the specimen and prevent further uncontained energy feedback, technicians deployed portable cryogenic suppression units, lowering the microenvironment around the container back to sub-zero temperatures. As the thermal suppression took effect, the 1.6 GHz signal pulses rapidly decayed, the low-frequency acoustic vibrations faded, and surface-level magnetic field readings returned to baseline levels. With the biological specimen safely stabilized inside a hardened containment vessel, the research team refocused their investigation on the adjacent metallic bulkhead. The temporal synchronization between the specimen's metallic tissue layer and the subterranean portal indicated that the biological entity and the Mesa infrastructure were part of an interconnected technological framework. To evaluate what lay beyond the portal without disturbing the structural integrity of the door, materials scientists utilized high-frequency ultrasonic reflection testing and gamma-ray radiography. The return density maps revealed that the bulkhead was not a monolithic slab of metal. It was a multi-layered barrier roughly 14 inches thick, featuring internal air gaps and vertical conductive channels lined with high-purity copper and carbon compounds. More significantly, ultrasonic reflection data indicated a massive subterranean void directly behind the portal. A descending passageway sloped at a 25-degree downward angle, extending hundreds of feet deeper into the basement rock beneath the Uinta Basin. As technicians cleared away accumulated silt along the base of the door to position ground-penetrating radar units, they uncovered a narrow clearance where the metal frame met the vitrified bedrock, opening a pathway for direct optical exploration deeper into the mountain. The discovery of the narrow clearance beneath the base of the bulkhead offered an immediate, non-destructive route to explore the space directly behind the titanium-nickel barrier. Operating under strict containment protocols, technicians initialized a tethered micro-rover equipped with solid-state LiDAR, passive optical cameras, and broad-spectrum electromagnetic sensors. The compact unit was carefully guided through the narrow horizontal gap, stepping across the threshold into the dark, descending corridor beyond. The live video feed transmitted back to the command monitors inside the upper chamber revealed a striking architectural transition. The linear tool marks and rough-hewn surfaces of the forward entry shaft vanished entirely. In their place stood a continuous, smooth passageway, whose ceiling, floor, and sidewalls were composed of a dark, vitrified silica matrix, sandstone that appeared to have been flash-fused at extreme temperatures into a seamless obsidian-like sheath. The passage displayed no structural joint lines, timber supports, or mechanical fasteners, resembling the interior of an artificially heat-molded energy conduit. As the micro-rover navigated down the 25-degree vitrified slope, environmental telemetry logged anomalous physical gradients that defied standard deep Earth behavior. Typically, ambient temperatures rise predictably with subterranean depth due to geothermal gradients. Inside the vitrified shaft, however, ambient air temperatures plummeted continuously, dropping past freezing and stabilizing at a chilling 24 degrees Fahrenheit. Concurrently, the rover's onboard triaxial magnetometer registered localized magnetic field spikes fluctuating between 0 and 1.8 Tesla, magnetic field strengths comparable to those generated inside medical imaging scanners. 80 feet down the vitrified ramp, the passage expanded dramatically into a vast subterranean vault measuring over 120 feet diameter. The structural layout of this lower chamber was dominated by 6 massive support columns crafted from dark basalt rock, each wrapped in fine, spiraling ribbons of an unidentified conductive metallic alloy running from the floor into the domed ceiling. Positioned in a precise geometric circle around the center of the vault were 6 elevated stone pedestals. Mounted atop each pedestal was a polished housing unit constructed from the same carbon nanotube titanium matrix identified in the upper bulkhead. Secured inside these metallic housings were multifaceted crystalline blocks, each roughly the size of a standard desktop computer chassis. Under the specialized illuminators of the micro-rover, the crystalline structures exhibited a subtle internal photoluminescence, glowing with a cold blue-green light across the ultraviolet spectrum. Initial spectroscopic readings taken off the surface of these blocks revealed that they were composed of ultra-pure synthetic silicon carbide infused with heavy metallic isotopes, a structural configuration utilized in modern high-power semiconductor, manufacturing, and quantum computing experiments. Directly beneath the central pedestals, ground-penetrating acoustic sensors mapped a massive multi-ton subterranean mass embedded within the floor strata, matching the high-density structural returns previously flagged by surface cosmic ray muon scans. Furthermore, acoustic mapping rendered 3 distinct subterranean corridors branching outward from the main lower vault like spokes on a wheel. The west conduit, a horizontal vitrified shaft extending westward, crossing beneath the property line toward unexcavated public lands. The south conduit, a secondary passage pointing due south, terminating directly beneath the ranch's central pasture, the precise area historically linked to high concentrations of soil sterilization, localized thermal anomalies, and unexplained atmospheric events. The deep axis, a vertical sloping shaft descending at a 35-degree angle directly into the ancient basement rock of the Uinta Basin, reaching depths where sensor resolution reached its physical limits. Before the micro rover could approach the central pedestals for close-range material sampling, a sudden voltage surge spiked through its primary battery management circuit. The optical feed briefly rendered a faint, self-luminous blue haze, coalescing in the ambient air above the central pedestals before the signal collapsed into total static. Simultaneously, surface monitoring crews radioed down to report that wideband radio spectrum receivers across the Mesa top had logged another sudden sequence of rhythmic 1.6 GHz pulses, confirming that the subterranean vault remained an active power-handling network. The sudden loss of the micro rover's optical feed and the appearance of the self-luminous atmospheric haze forced researchers to halt all physical progress along the vitrified ramp. Facing an active power-handling network capable of discharging intense electromagnetic surges, project managers authorized a non-conductive passive diagnostic approach. To analyze the lower chamber without introducing metallic components or live power supplies, technicians deployed a hardwired, fiber optic endoscope coupled with a high-sensitivity passive acoustic array down the edge of the descending passage. As the fiber optic lens reached the base of the ramp and rotated upward, high-definition optical feeds rendered a clean, uninterrupted view of the lower cathedral. The scope confirmed that the central silicon carbide crystalline blocks had returned to an inert state, their blue-green photoluminescence fading back into the dark stone surroundings. With the ambient electrical activity temporarily grounded, the optical team was able to conduct a detailed visual survey of the floor perimeter surrounding the central basalt pedestals. Resting near the eastern support column, half buried beneath a thin layer of wind-blown silt and pulverized sandstone, lay physical evidence that directly linked this hidden subterranean facility to modern human history. Positioned against the dark basalt wall were several heavy industrial-grade transit cases and degraded aluminum junction boxes bearing nondescript defense contractor logistics markings. Beside the corroded cases lay severed bundles of early-generation fiber optic lines and heavy copper-shielded coaxial cables that had been routed directly toward the base of the crystalline pedestals. Serial numbers and contractor identification codes stamped into the aluminum casings matched procurement registers from the late 1980s and early 1990s, a period when covert government precursors and private defense entities were actively operating covert monitoring stations throughout the Uinta Basin. The presence of these physical assets provided verifiable proof that modern investigators were not the first to breach the Mesa interior. Specialized military-sponsored teams had accessed the lower vault decades earlier, attempting to monitor and tap into its central power distribution nodes. However, the physical condition of the left-behind hardware painted a chaotic picture of the previous expedition's departure. Heavy lead-shielding plates had been dropped where they stood, diagnostic oscilloscopes lay smashed against the rock floor, and several primary data cables leading into the pedestals had been cleanly fused at their connectors. The terminal ends of the copper wire harnesses exhibited severe heat-induced spalling, unmistakable evidence that the earlier research team had encountered an explosive energy feedback loop that overloaded their hardware and forced an abrupt, emergency retreat. While camera operators documented the legacy contractor hardware, environmental sensors lowered through the fiber optic conduit logged a sudden change in the vault's physical state. The ambient air temperature near the central pedestals began rising rapidly, climbing from 24 degrees back up to 65 degrees Fahrenheit in less than 10 minutes. Simultaneously, the low-frequency 19 Hz acoustic hum that had previously induced spatial disorientation vanished entirely, replaced by absolute environmental equilibrium. The localized magnetic field fluctuations collapsed back to normal baseline levels, and the broad-spectrum 1.6 GHz radio transmissions ceased as abruptly as they had begun. This return to equilibrium presented the team with a brief, stable window of opportunity. The lower vault had temporarily returned to a dormant state, but the cumulative empirical data painted a startling picture. The Mesa subterranean network was not a natural geological cave or an abandoned mining drift. It was a vast, interconnected, and technologically responsive deep Earth facility, physically and electromagnetically tied to the exact locations where anomalous phenomena had been logged for decades. With environmental parameters holding steady, project leaders approved a two-person entry team to descend the vitrified ramp on foot, secure the disabled micro-rover, and perform direct material sampling on the legacy contractor gear left behind in the dark. Equipped with non-magnetic, anti-static suits and hardwired atmospheric monitors, two field specialists stepped past the unsealed bulkhead and descended the vitrified ramp on foot. The air inside the lower cathedral felt unexpectedly fresh. The stagnant metallic smell that had filled the upper entry shaft had completely cleared, replaced by a steady, cool draft flowing upward from the deep third shaft, the conduit penetrating directly into the ancient basement rock of the Uinta Basin. Reaching the floor of the lower chamber, the team's primary task was to document the legacy equipment and retrieve the disabled micro-rover. Up-close examination of the left-behind contractor transit cases confirmed their late 20th century defense origin. The corroded aluminum junction boxes housed early-generation digital signal processing units, high-voltage transformers, and heavy lead-lined shielding blocks designed to withstand intense electromagnetic interference. The physical state of these components provided clear technical context for what had occurred decades prior. The severed coaxial cables leading to the basalt pedestals showed heavy electrical arc welding along their copper leads, evidence of a massive reverse current surge. Rather than drawing power out of the subterranean network, the early contractor equipment had inadvertently completed a high-voltage circuit, triggering a sudden discharge from the core that destroyed their diagnostics and forced an immediate, uncontained evacuation. While one specialist photographed the corroded logistics markings on the transit cases, the second technician secured the damaged micro-rover. Visual inspection showed that while its carbon composite chassis remained structurally intact, its internal lithium-ion battery housing had suffered severe thermal swelling, and its solid-state control boards bore the distinct rainbow-hued burn patterns of high-intensity electromagnetic induction failure. To evaluate the current state of the central pedestals, the team swept handheld multi-spectrum analyzers across the synthetic silicon carbide crystalline blocks. The crystals remained dark and inert, but direct surface spectroscopy on the carbon nanotube titanium housings revealed persistent microscale surface charges. The metallic housings were acting as giant capacitive storage units, holding residual energy from the recent 1.6 GHz transmission event. As the technicians finished packing the recovered hardware into shielded transport cases, a new acoustic pattern registered on their audio diagnostic monitors. Far down inside the downward-sloping third shaft, extending steeply beneath the lower vault, a low, rhythmic pulse began to echo through the stone. Unlike the earlier 19 Hz infrasound hum, this new signal operated at an ultra-low frequency between 3 and 30 Hz, acoustic waves capable of propagating hundreds of miles through Earth's crust without losing amplitude. The rhythmic pulsing indicated that the lower cathedral was not a standalone terminal node. It was an active junction point in a much broader, deep Earth communications and energy distribution network operating directly beneath the high desert floor. With their physical mission parameters met, and the ambient energy levels in the chamber beginning a slow upward climb once again, the specialists gathered their equipment and began their ascent back up the vitrified slope toward the upper entry corridor, leaving the deep lower vault to settle back into its dormant, self-sustaining state. The physical documentation of the Mesa interior, its vitrified silica conduits, synthetic silicon carbide nodes, biosynthetic biological specimen, and left-behind late 20th century contractor hardware marks a decisive turning point in the history of Skinwalker Ranch. For generations, public understanding of the property fluctuated between regional folklore, eyewitness accounts of high strangeness, and unverified atmospheric anomalies. However, the physical recovery of engineered titanium-nickel matrices, fused sandstone pathways, and synchronized 1.6 GHz electromagnetic broadcasts grounds the entire mystery in tangible, material physics. The empirical evidence gathered throughout this subterranean investigation establishes several concrete findings: engineered subterranean facilities. The Mesa is not a natural cave system or a passive geological formation. It houses an artificially constructed, multi-level facility featuring fused silica corridors, basalt support columns, and carbon nanotube titanium bulkheads built with high-energy precision. Autonomous biosynthetic systems. The 4-foot biological specimen recovered at the threshold of the lower chamber represents an advanced biosynthetic interface. Its cartilaginous skeletal frame, non-human cranial structure, and titanium-nickel dermal scales indicate an engineered autonomous entity designed to endure high thermal, pressure, and electromagnetic stress without standard biological degradation. Synchronized environmental networks. Real-time telemetry confirms that surface-level events across Skinwalker Ranch, including localized 1.6 GHz radio frequency bursts, sudden magnetic spikes exceeding 1.8 Tesla, thermal drops below freezing, and atmospheric optical distortions over the central pasture, are direct surface manifestations of an active, deep Earth technological core undergoing automated recalibration cycles. Prior covert exploration. The physical recovery of corroded, lead-shielded transit cases and arc-welded coaxial cables confirms that covert defense entities investigated this subterranean network in the late 1980s and early 1990s, encountering high-energy discharges that forced an abrupt emergency retreat. Despite these significant material breakthroughs, fundamental scientific questions remain unresolved. Researchers must carefully distinguish between verified physical evidence and broader theoretical interpretations. The physical presence of synthetic crystalline blocks, engineered composite alloys, and wideband electromagnetic broadcasts is an established material fact. However, the original identity of the facility's builders, its absolute operational age, and its broader planetary purpose remain open to ongoing scientific inquiry. Investigators have not yet determined whether this subterranean network was constructed as an ancient non-human monitoring station, a covert Cold War defense project that surpassed human technical control, or an automated deep Earth energy node operating outside current technological paradigms. Furthermore, the downward-sloping third shaft, extending steeply into the ancient basement rock of the Uinta Basin toward depths where extreme temperatures and rock pressures should make open voids impossible, remains unexplored due to extreme depth constraints and severe magnetic gradients. As multidisciplinary research teams continue to analyze the recovered material samples, map the radiating subterranean conduits, and monitor the ultra-low frequency signals pulsing from the deep basement rock, the unsealed Mesa network stands as a profound physical reality. The ongoing investigation at Skinwalker Ranch has permanently moved past regional legend, leaving behind a clear, empirical record of an advanced subterranean infrastructure embedded beneath the high desert floor of Utah. The ultimate question facing modern science, history, and engineering is no longer whether an artificial structure exists deep inside the Mesa, but rather, who originally engineered this silent subterranean network, and what purpose does it continue to serve deep within the Earth?